Okay, let's jump right into this. Welcome to today's Explainer, where we are diving headfirst into the incredibly complex biological machinery of the human hand and wrist. We use our hands every single day without a second thought, right? But just underneath the skin lies an absolute marvel of precision engineering. Today, we're going to explore exactly how this intricate system works, what happens when it completely breaks down under the intense stresses of trauma and sports, and how modern orthopedic medicine manages to put the puzzle back together. To kick things off, just think about this staggering statistic from our sources. Literally 1 in 4 of all sports injuries happen right at the ends of your arms. A quarter! But honestly, it makes sense when you think about it. In almost any sport, your hands are your primary interface with the world. You fall, you put your hands out to catch yourself. You need to defend yourself, hands go up first. This massive rate of injury makes understanding wrist pathology absolutely essential for anyone in the field. And when you look at the sheer density of the anatomy here, this incredibly intricate arrangement of 8 tiny carpal bones perfectly nestled between your forearm and fingers, it's super easy to see why this area is so vulnerable to impact. This is a highly specialized system designed for fine, complex, delicate movements. It is not designed to bear massive weight. So when things go wrong here, it requires some very meticulous care. So here is our roadmap for this explainer. We'll start with the anatomy and biomechanics, then look at common fractures and diagnostics, move into treatment protocols, and finally wrap up with the athlete's dilemma. Let's get right into it. All right, part 1, anatomy of the hand, our finely tuned biological machine. Which leads us perfectly into part 2, biomechanics and radial indices, or what I like to call precision engineering. Now, you might be wondering, why do orthopedic surgeons absolutely obsess over millimeter-precise angles and ligaments in the wrist? I mean, why isn't close enough actually good enough when you're repairing a fracture here? Well, it basically comes down to 3 incredibly crucial biomechanical measurements that we call the radial indices. These specific measurements perfectly govern our hand's functionality and its ability to properly carry and distribute loads. If a surgeon misses the mark on these exact measurements after a break, the patient could literally lose their range of motion permanently. Okay, so the first index we look at is the palmar or volar tilt. The end of your radius naturally tilts forward at an angle that's normally between 11 and 12 degrees. This specific tiny angle is absolutely vital for your ability to flex your wrist forward smoothly. If a fracture heals and this bone ends up tilted backward instead, you simply wouldn't be able to bend your wrist properly to do basic everyday tasks. Next up is radial inclination. This is the angle sloping toward the ulna, normally sitting right around 20 to 23 degrees. This specific slope is what allows your wrist to perform ulnar deviation. You know, that side-to-side waving motion? That movement is completely essential for a natural and complete range of motion. And finally, our third big measurement is ulnar variance. This measures radial shortening, basically showing us the vertical distance between the joint surfaces of the radius and the ulna. It dictates exactly how mechanical load is distributed across the entire joint. If this variance is off, say a bone healed just a bit too short, the pressure in the wrist becomes entirely unbalanced. We're talking severe pain and early onset arthritis for sure. Moving on to part 3, common fractures and causes. Basically, what happens when the machine breaks? When we look at a beautifully healthy proximal carpal row and contrast it with a dangerous, displaced injury, it really paints a picture. This kind of severe displacement is typical of what happens when the wrist is hyperextended past 95 degrees with a heavy axial load. The forces literally just shear and compress the bones. Ligaments tear, and the carpal bones are completely shoved out of that highly specific, perfect alignment we were just talking about. Which brings us to part 4. Diagnostics and imaging, or finding the fault. Diagnosing these specific injuries isn't always a walk in the park. Doctors often have to play detective, hunting for occult or hidden fractures, especially in the scaphoid bone, because those might not even show up on an initial X-ray. They're also scanning for some pretty surprising visual clues, like the Terry Thomas sign. This is a pathological widened gap between the scaphoid and lunate bones that points to a severe ligament tear. And yes, it was actually humorously named after the famously gap-toothed 1950s British actor Terry Thomas. Kind of funny name, very serious injury. All right, part 5, treatment protocols, traction, fixation, and healing. Once they find the problem, the medical team essentially has to weigh 2 main paths. You've got conservative treatment, like casting, which relies heavily on strict immobilization in a functional position. On the flip side, you have your surgical options, like plates or pins. Surgery is usually reserved for those high-energy, unstable, or heavily comminuted injuries, where the bones are just completely shattered and won't stay put on their own. For the conservative route, casting is the go-to, but man, it has its challenges. Our source material actually shares this fascinating real-world story about a 65-year-old patient who aggressively refused to wear a bulky splint. It perfectly highlights the tightrope that doctors walk. You absolutely must protect the healing bone, sure, but you also desperately need to prevent severe stiffening or the onset of complex regional pain syndrome, which is devastating. That's exactly why, even when casted, getting those fingers moving early is critical. Now, for the really severe cases, surgeons break out one of the most striking tools in orthopedics, the external fixator. This is a literal metal scaffolding system. They drill pins directly into the bone above and below the fracture and then connect them with rigid bars right outside the skin. It looks intense, but it's used to literally pull a complex, shattered fracture apart using tension. This allows all those tiny bone fragments to align and heal safely without having to slice the entire wrist wide open. So, the whole magic behind external fixation and joint spanning traction is that it combats those irreducible fractures. By rigidly holding the bones in space using the tension of the surrounding ligaments, it literally stops the bones from collapsing into each other. But most importantly, it perfectly preserves those precise radial indices we obsessed over earlier, the angles, the length, the whole shebang, all while letting the patient wiggle their fingers early on to fight off joint stiffness. It's truly brilliant. And finally, part 6, the athlete's recovery dilemma, health versus wealth. This quote from the medical notes, it is incredibly telling. The source specifically warns physicians to avoid creating coach's finger. This really shines a bright light on the dangerous commodification of athletes. You know how it is. There's this immense, crushing pressure from coaches and sponsors to get a player back on the field way before they are fully healed. If doctors cave to that pressure, they risk leaving the athlete with a permanently stiff, painful joint. We're talking about something that could ruin not just their career, but their lifelong hand function. Hey, really quick, speaking of journeys, if you want to help us make more of these deep dive medical explainers and start your own earning journey earlier with access to fan funding and exclusive shopping features, please take a second to comment, share, and subscribe. It truly helps the channel out. And that leaves us with a pretty provocative thought to wrap up on. As sports medicine keeps rapidly advancing and the financial stakes of professional sports skyrocket, how do we, and how do the athletes themselves balance that massive pressure to return to play against the long-term health of the body's most finely tuned machine? It's a tough call and a question every single sports physician wrestles with. Thanks for hanging out with me for this explainer, and I will catch you in the next one.